Ever wondered how the fan regulators in your home control the speed of fan or brightness of a light bulb? In today's video, we will delve into the fascinating world of fan regulators or light dimmers and try to demystify the working principle and functionality of these devices. So what's inside a fan regulator? Let's crack it open and take a peek. You will find four key components: the Diak, Triak, capacitor, and a resistor. These components can be represented with electrical symbols as follows, and they will connect in fan regulator circuit diagram like shown. But before we delve into the circuitry, let's unravel the mysteries of Diak and Triak. Diak, short for diode for alternating current, is used with AC signals. A Diak is internally made of two anti-parallel diodes. It is because of this, Diak can pass current in both directions. A Diak functionality can be understood with its voltage-current graph. We assume that an AC signal has been provided to a Diak. At time 0, AC voltage value is 0 volts. This is why no current is flowing through the Diak terminals. Slowly, AC voltage starts increasing, but because AC voltage has not yet reached the Diak breakdown voltage, Diak still conducts a very small amount of leakage current. Between 25 to 40 volts of applied AC, Diak breakdown voltage is reached, and as soon as this voltage is reached, Diak starts conducting a heavy current through it and acts as a short circuit. In the same fashion, in the negative half cycle of AC waveform, Diak becomes fully conducting after its breakdown voltage. In other words, Diak will only flow short circuit current through it when the AC voltage across it is higher than its breakdown voltage. After understanding a Diak functionality, now let's understand how a Triak works. Triak full name is Triode for Alternating Current, and just like Diak, it's used for AC signals. Similar to Diak, Triak is also made of two anti-parallel diodes. However, Triak has an additional terminal which can be used to control the flow of electric current through the Triak. This third terminal is called gate terminal. Whenever a small trigger current will be applied at the gate terminal of Triak, Triak will turn on and conduct bidirectional current. Once turned on, Triak will keep conducting electric current through it until the applied voltage on Triak main terminals reduces to 0. At this point, Triak will turn off. After understanding the Diak and Triak functionality, it will be easier for us to comprehend fan regulator working principle. Let's now try to understand the working principle of a fan regulator with its circuit diagram. In the circuit diagram shown, we can see four circuit elements. These are variable resistor, capacitor, Diak, and a Triak. For ease, we will represent these components with their electrical symbols and see how the circuit is operating at time 0. At time 0, AC voltage is applied at fan regulator terminals. At this time, Triak is in off condition. As a result, no current is flowing through the fan. At this instance, the capacitor present inside the circuit starts charging through the variable resistor. After some time, the capacitor voltage will reach the triggering voltage of Diak. The time in which the capacitor voltage reaches the triggering voltage of a Diak can be changed by changing the variable resistance value. At this time instance, Diak turns on and capacitor voltage gets applied through Diak on Triak terminals. This will make the Triak turn on, causing AC current to start flowing in fan through Triak. However, Triak will not remain on indefinitely. As soon as AC voltage will finish its positive half cycle, Triak will turn off and current flow in the fan will become 0. Now in the negative half cycle of AC signal, capacitor will similarly charge in the opposite polarity, and as soon as it reaches the Diak triggering point, it will trigger the Triak through Diak. As a consequence, fan will also turn on for some time in the negative half cycle of an AC signal. Now because an AC signal source in homes complete 50 cycles in 1 second, This means that in 1 second, a fan will turn on and off 100 times. As a result, fan speed will effectively reduce. To change the speed of the fan, we will need to change the value of a variable resistor in the circuit. If the resistance value is smaller, capacitor will charge in lesser time and will reach the trigger voltage of a Diak faster. As a result, fan will remain on for longer period in one cycle of an AC signal, and consequently it will lead to higher speed. In the same manner, if the resistance value is increased, capacitor will charge slower, consequently reducing the speed of the fan. And there you have it, the fan regulator's clever use of its components to control fan speed. If you found this video enlightening, show us some love by liking, sharing, and subscribing. Thanks for tuning in.